My dear students, today the topic of discussion is on degree of freedom and kinematic inversion of Kinematics and Theory of Machine Module 1 Part 2B PCME 503, that is third year 5th semester. Now what is degree of freedom? The degree of freedom of a mechanical system is the number of independent parameters that define its configuration or state. Now, translational motion along any three mutually perpendicular axes, that is x, y and z, and rotational motion about three axes also. A rigid body possesses 6 degrees of freedom. Now, degree of freedom of a pair is defined as the number of independent relative motion, both translational and rotational, a pair can have. So, a degree of freedom of a pair is nothing but 6 minus number of restraint. Now, in the first diagram, one rectangular block is inside another rectangular block. So, there is only movement in translational motion in one direction and other motions are restricted. So, in this case, the degree of freedom is 1. In the second diagram, that is one plate is on another plate, so there is a movement in the two direction x and y in the translational motion, and in the z direction the motion is translatory motion is restricted. Similarly, the rotary motion is z direction is also there and other rotary motion is restricted. So in this case, the degree of freedom of this pair is 3. Now similarly, in the third diagram, a circular shaft is inside a circular hole. So in this case, the motion of the shaft is the translatory motion of the shaft in this particular axis is there, and also the rotational motion of that same axis. So in this case, the degree of freedom of this shaft is 2. Now, the classification of pair based on degree of freedom. A free body in space has 6 degrees of freedom. In forming a kinematic pair, one or more degree of freedom are lost. The remaining degree of freedom of pair can be used to classify pairs. So, degree of freedom of pair equals to nothing but 6 minus number of restraints. A kinematic chain can therefore be classified on the basis of number of restraint imposed on the relative motion of the constrained links. Now in the first diagram, diagram A, a sphere moving on the flat plane. So in this case, the number of restraint on the translatory motion, that is only 1, and there is no restraint in the rotary motion. So the total number of restraint is 1. In this case, it is in the class of pair 1 and its degree of freedom is 5. In the diagram B, that is a sphere inside a cylinder, in this case the number of restraint on the translatory motion, that is 2, and there is no restraint in the rotary motion. So the total number of restraint is 2. So it is in the class of pair 2 and its degree of freedom is 4. In the diagram C, a cylinder moving on a plane. So in this case, the number of restraint on the translatory motion, that is 1, and rotary motion is also 1. That means there are 2 restraints. So it is in the class of pair 2 and its degree of freedom is 4. In the diagram D, that is sphere in spherical socket. So in this case, there are 3 restraints. There are 3 restricted motion in the translatory motion and there is no restriction in the rotary motion. So the total number of restraint is 3. So in this case, it is in the class of pair 3 and its degree of freedom is 3. In the diagram E, that is the sphere in a slotted cylinder. In this case, the number of restraint in the translatory motion, that is 2, and number of restraint in the rotary motion is 1. So total number of restraint is 3. So it is in the class of pair 3 and its degree of freedom is 3. Similarly, in the figure F, so prism on a plane. So the prism on a plane, it is the number of resistance on translatory motion, that is 1, and the rotary motion, that is 2. So total number of resistance is 3. So it is the class of pair 3 and its degree of freedom is also 3. So in the diagram G also, the spherical ball in a slotted socket. So in this case, the total number of resistance on a translatory motion, that is 3, and the rotary motion, that is 1. So total number of resistance, that is 4. So it is the class of pair 4 and the degree of freedom is 2. Now in the next diagram, that is the diagram 8, a cylinder within a cylinder. So in this case, there are two restrictions in the translatory motion and the two restrictions in the rotary motion. So the total number of restriction, that is the 4, and it is the class of pair 4 and the degree of freedom is 2. And in the next diagram, that is the collared cylinder within a cylinder. So in this case, the number of resistance on the translatory motion, that is 2, and the number of resistance in the translatory motion is 2, and the number of resistance in the translatory motion is 3, and the number of resistance in the rotary motion, that is 2. So the total number of resistance, that is 5. So in this case, it is the class of pair 5 and the degree of freedom is 1. So and the last one, that is the prism inside a hollow prism, that is the total resistance in the translatory motion, that is 2, and the rotary motion, that is 3. So total resistant, total restricted motion, that is 5, and it is the class of pair 5 and its degree of freedom is 1. Now inversion of mechanism. So what is inversion of mechanism? A mechanism is one in which one of the links of a kinematic chain is fixed. Different mechanism can be obtained by fixing different links of the same kinematic chain. This method of obtaining different mechanism by fixing different links in a kinematic chain is known as inversion of mechanism. So there are three types of kinematic chain. One is 4-bar chain, number 2 single slider crank chain, and double slider crank chain. Now 4-bar chain. So what is 4-bar chain? Quadric cycle chain. The simplest and basic kinematic chain is 4-bar chain. It consists of 4 links. Each of them formed a turning pair A, B, C and D. The 4 links may be different lengths. So according to Grashopp's law, for a 4-bar mechanism, the sum of the shortest and longest link length should not be greater than the sum of the links length of the other 2 if there is to be continuous relative motion between the 2 links. Now beam engine, it is also crank and lever mechanism. The end E in the diagram, the end E of the lever CDE is connected to a piston rod which reciprocate due to the rotation of crank. In other words, the purpose of this mechanism is to convert rotary motion into reciprocatory motion. Now coupling rod of a locomotive, that is double crank mechanism. In this mechanism, the link AD and BC, so these two having same length, act as a crank and the connected to the respective wheel. The link CD acts as a coupling rod and link AB is fixed in order to maintain a constant center to center distance between them. This mechanism is meant to transfer rotary motion from one wheel to another wheel. What's in number 3, Watt's indicator mechanism, that is also called double lever mechanism. It consists of 4 links. Fixed link, link AB and DE act as levers. The links AB and DE are parallel in the mean position of the mechanism, and coupling rod BD is perpendicular to the levers. On any small displacement of the mechanism, the tracing point C traces the shape of number 8, a portion of which will be approximately straight. Thank you.